Hi, everyone. Thanks for joining us today. My name is Caroline Griffin. I am Riot's Director of Operations. You have found the Riot Lunch and Learn series, the place where we showcase all of Riot's partners. I'm very excited to have Joe Kunz and John Hogie with Google Fiber here today. Just a couple of quick reminders before we get started. This session is being recorded and will be posted to Riot's YouTube channel, and you will be able to find it on the meetup page where you registered for this event. If you have any questions throughout the event, please do place those in the chat box and I will make sure all of your questions are answered at the end. Last reminder, please do keep yourself muted throughout the event and utilize that chat box if you have any questions or concerns. But without further ado, I'll hand it over to John and Joe. Thanks for being with us today.
All right, thank you, Caroline. So as Caroline said, we are Google Fiber, and we're excited today to come and talk with y'all about our approach to innovation, specifically around the hardscape trenching space. So for introductions, I'm John Hogie. I'm a program manager in Texas, and I'm on the operations team. With me today is Joe Kunz. He's also a program manager who works on the standards, quality, and deployment strategy team. Today, we're going to cover 3 areas. So the first being innovating as an owner-operator, secondly, moving to learning through iteration, and then finally, a local success story here in Austin, Texas. So with that, I will hand it over to Joe.
Thanks, John. Hey, everybody, I'm Joe. Like John said, I work on our central strategy and standards team. And before we got into any kind of specific examples, of our iteration process and innovations in some of the hardscape trenching that we've done. We wanted to talk a little bit about our general approach to innovation as an owner-operator, as well as being a part of Google and what all kind of comes with that. Google's obviously well known in the innovation space. There are terms you've heard that come out of Google around moonshots and launch and iterate and fail fast, and they're kind of those traditional Silicon Valley innovation principles. And it's something we still try and hold true to as much as we can. But over time, we've really learned, there are unique challenges to being an owner operator of a fiber network or a utility operator in general that need to be considered on top of these kind of quick, iterative innovation approaches that Google's well known for. And what those kind of fall into a few buckets that we kind of layer on top of that Google approach to innovating. One of them is that the platform that we innovate on and the environment that we're in is not always necessarily ours, unlike Google or some of our other Silicon Valley companies where they're operating within a platform that they own. It's theirs to do what they want with. We're often not in that environment. We're in the right of way of our municipal partners. We're on private property. And another aspect to that is that platform varies drastically from an Austin, Texas to a Salt Lake City. Geotechnical considerations and things vary drastically. We're not on a standard platform like Google may be in some of their work. We also have to really consider the higher capital investment that comes with some of the R&D that we do. That's not always the case, but there are things that we may want to pursue where there's a very large upfront capital investment to even get that R&D process off the ground, as well as over time if there's additional OpEx and operational cost considerations that we need to make to maintain a trial, to maintain some kind of R&D approach that we've put out there. Those are kind of big considerations when we start to look at something we want to innovate on. And a big one is always the consideration for our partners. We're not in this alone on a lot of these. Like I said, we're in the right of way or we're in the private property of a partner of ours, and we really need to consider their needs and their input before we start to deploy this in any kind of right of way or anything that would impact our partners. And one really big one is difference between us and Google is that our innovations and our rollouts are much slower and they're not necessarily easily rolled back. So if we were to put something out there, we need to be very cautious and kind of slow that rollout because it's not something we can flip the switch and kind of quickly roll back. Next slide. So to make sure that we are really operating through both lenses, that we kind of maintain our Googliness in our innovation approach and our R&D pipeline, while also being a responsible owner operator of a fiber network, we kind of hold ourselves to just kind of 4 pillars in our innovation process. And these are kind of broad and they can fit in a lot of different use cases, but generally we want to make sure we have a sustainable lifetime to whatever approach we're putting out there, especially in the deployment side, that we know we're getting at least a minimum useful life out of whatever network we're putting out there of 20 years, which doesn't necessarily mean we just put it out there and it lasts 20 years. Like all of us in the telecom, we know there's operational cost to anything we put out there. But essentially, this is just making sure that we're not pushing too much to the OpEx side while trying to save CapEx, or we're not moving things too much around in that kind of P&L structure of CapEx versus OpEx. Survivability, and this comes into play when we talk about our shallow trenching that we've put out there. We know we need to maintain routine events that happen out in the right of way, routine events that happen to our network. We can't be responding to every mill and pave event. We can't be responding to every, small windstorm. We need to be survivable to kind of routine events. This may not cover large capital projects. We all know we need to relocate for certain things, but general routine survivability we need to meet. One that's come into play over time is the constructability piece. We also don't want to put out an R&D or a approach to deploying our networks that is heavily craft sensitive, where we're creating a new labor skill that somebody would need to be trained up on. Obviously, some things we do are slightly different, but as long as they fall into the bucket of our contractor or vendor base being able to handle it without a lot of unique training, that's what we're trying to meet with that. And then repairability is just that if something does break, whether through a routine event or a capital project, or somebody strikes us, that it is repairable, and really kind of falls in that lifetime piece as well, that we can repair our plant at a reasonable time and cost over that 20 years. Next slide. So to make sure we're holding ourselves to both sides of that coin, the Google innovation, but making sure that we're kind of hitting all of those principles of being an owner operator of a fiber network, we've kind of set up gates for ourselves, that we work anything that comes through our R&D pipeline through these gates. And really step one is pure Google, really. Anyone who has an idea, the hypothesis and brainstorm piece, my team will engage with people across the org and talk with them about what their idea is, what the problem they're trying to solve is. And there's really no, the cliche of no bad idea in the brainstorm. We'll hold true to that. But to get through that brainstorming phase, we really just need to answer 2 questions. Is the problem that we're trying to solve worth solving for us? Is it like a 1 in a million anomaly that's not worth the resources we're going to put into it? Or is it a problem that we really need to solve? And will this use case benefit us? And if the problems we're solving, is it reasonable to assume that whatever this solution being proposed is, will solve that problem? So, that filters some things, filters a lot actually. But once you get through that, and we have a problem and a use case we're trying to solve for, that's when we put pen to paper on really the business case for the idea. And you can see this kind of goes up in level of effort. Brainstorming doesn't take a lot of time. Putting pen to paper on a business case is a bit more of an effort, but still a very low risk activity. So we'll move things into this phase often. But what we need to prove out here is that 20-year total cost of ownership, our P&L, all of these financial models actually benefit from this idea, and that we're not necessarily just moving air around a balloon, which is how it's been explained to me many times, is that, if I'm just pushing CapEx to OpEx, and I'm moving the air around the balloon, that may not make my total cost of ownership worthwhile. What we're really trying to do is prove that we're taking air out of the balloon in this step and not just kind of moving things around. And one nice part to this step in the process is we do also find ideas that come through here that may not necessarily make sense for our business model, our P&L, but it may make sense for one of our partners, one of our manufacturers. And oftentimes this may spin out into an engagement with a partner that may be interested in this, and we can just act as their guinea pig. But if it makes sense for us and our business model, and we can prove that out on paper, then we'll move it into a physical trial. And this is where it starts to get fun. So step 3 is really a very small trial. Most likely these start in one of our private facilities where we own the land. It's fully the risk of ours, whatever happens. And potentially could move into, small trial with a HOA partner that we're comfortable with, we worked with in the past. But typically we do this on our own, in our lab or on our own property. And what this is getting enough of a sample size to prove out all the assumptions we made in the business case. So we've set up success criteria, things that need to be proven out in the business case to make this viable. And this is where we do that on a small scale. I'll also point out this is the tricky part where you can get stuck in your own feedback loop, where you may meet some of your success criteria, you may not meet others, and you kind of iterate on yourself a lot. But this is one of those points where we hold ourselves true to that fail fast principle of if we've proven it doesn't work, move on, unless there's some step function change or some real large change in our business assumptions, then we're not going to try and iterate it on it a lot. And I'll give an example of that next. So if we have proven it out with a reasonable sample size, we feel comfortable that the assumptions work and it's technically feasible. That's when we'll actually, by the time we get to step 4, this is where we may engage our municipal partners, folks who have jurisdiction over the right of way, and begin to explain the idea to them, and start to talk about a trial in their right of way, a controlled release of this deployment, really depending on what the innovation we're putting out there is. And this is where we get into the more structured standardization of the process or the deployment method. And we start iterating with that with the municipal partner we're with other teams within Google. And this step 4 is where it actually starts to take shape into a formal method or technology that we may use. And if we get through that with a municipal partner or private partners, if we're talking maybe an MXU application, then we'll go into the full release, which step 4 to step 5 often takes a long time. But to get to 5, that means we've fully published a standard. All of our teams can use it. All of our vendors have kind of adopted it. And now it's just part of our toolkit in our network deployments. Next slide. So I wanted to give you all an example before we get into the success story that John will talk through. I wanted to give you a kind of success story. This is a R&D trial we did back a couple years ago. The idea was a surface mounted cable that we aptly named fiber tape, because we were essentially taping it to the road. And I'll walk you through why we consider this a success, even though the use case we originally thought we'd use it for turned out to not be viable. Like you can see, it is a surface mounted, it's actually a traffic tape, typically used for temporary traffic striping, just painted black. It's got a bit of a little channel in there to protect the fiber cable. And the use cases we were trying to solve for were really rural deployments and early penetration into a rural deployment, quick extensions, relocations, R&M applications, as well as potentially a secondary redundant path to something that would be the less reliable but redundant and used in redundancy to get us the reliability we're looking for. Next slide. So we took it through our funnel. Obviously, you can see we held true to Google in the hypothesis and brainstorm piece. It was kind of a wild idea, but it had use cases that needed to be solved and had the potential to solve them. So we took the pen to paper and we could prove out the total cost of ownership made sense for our business with that low cost deployment piece. One of the assumptions in that business case is lifespan before needed replacement. It was obviously much less than 20 years, but we had some assumptions around how long this would last in the right of way that made that total cost of ownership work. So moving to the small trial, we did one first in our private R&D facility. Then we really did one in with an HOA partner that we'd worked with in the past that was amenable to the idea. And we set up those two success criteria like we've talked about. There was a production rate kind of workflow assumption that drove a cost per house to meet the business case. And the second one was survivability, that it needed to last a certain amount of time before the replacement and the OpEx costs got too great to make business sense. Next slide. So when we were in that step 3, where we have a very small sample size that we put out there before we start to actually engage our municipal partners with this idea, we kind of had 2 steps to it. And step 1 was our private facility, where we wanted to make sure the material worked as planned, the workflow to apply it and the construction workflow was feasible, and really kind of all the application use cases worked. So when we did it in our R&D facility, that's a very small sample size. So we wanted to move on to a slightly larger sample size with an HOA partner that, if I recall, was maybe 50 or so houses in this HOA. So we worked with them, we designed it, we went out and deployed it. We proved that first success criteria, just like we assumed we would from our R&D trial, that the workflow worked and our cost assumptions made sense. That was great. Put it down, then we waited to make sure that as we checked in on that survivability assumption, it still made sense. What we had not accounted for in our business case was the primary failure mode was trailer hitches, gardeners coming up, dropping down their trailer to get a lawnmower out, whatever it may be. Every one of those severed our cable. So within 60 days, when we went to walk it, we hadn't actually lit anyone up yet. This was still dark at the time. But we went to inspect to see if we could still get light after 60 days. Multiple strikes, really just kind of crushed that survivability success criteria. And this is where you had to make that hard decision of like, all right, it did not pass. That was a requirement of the business case and it failed. So we kind of went back to the drawing board. Next slide. So you can see we got to step 3. We proved ourselves wrong. But by doing this funnel and before we even engaged a municipal partner, we really avoided a lot of additional capital investment. We avoided a large rollback. I mean, we never actually lit anyone up on this network until we weren't going to do that until we were confident. So we never actually had a customer rolled back off of this. And the replacement of it ended up being simple because we really controlled how much of it went out until we could prove ourselves correct in our assumptions. But the nice part about also holding us to Google's innovation principles to kind of launch and iterate is we looked at what failed. It does not last longer than 60, 100. We needed much longer than that for the business case to work. So the survivability did not work. And that really eliminated 2 of the use cases, the rural, the redundant pieces that we wanted to use it for. But there was one use case that did not really rely on that assumption of 60-day survivability or longer. And it was that R&M solution where we may have a a temporary relocation or a temporary repair that needs to be out there for less than a week, less than 14 days until we can get out there to do the permanent repair. So we kind of put it through the same funnel with the new assumption of, if this only works for R&M, we need it for 14 days. And you can easily pass all of these gates if your survivability is less than 2 weeks. So we ended up launching, iterating, launching again. And now this is actually a tool in our R&M toolkit for, minor quick repairs. If we need to hold the cable in place for a week, this works great. So this is a great example of failing, but also iterating and finding a use case that the technology works for. And I'll hand it off to John to talk through the shallow hardscape piece of this, which really made it through the whole funnel.
All right, thank you, Joe. So before I kick off talking through this slide here, I wanted to touch on the formatting a little bit because it's fairly busy. So at each one of the milestones, you'll see we tagged it with the step in the innovation funnel that ties to. One piece of that is that as you're working through the innovation funnel from over the course of 4 or 5 years, that it's not super clear as to which step in the funnel it is, and it can be sitting between, the business case and controlled release, or small trial and controlled release at the same time as you're moving through it. So as you look at these and you think, hey, this might fall into the business case, not small trial, probably some of these could fall into one or the other. But in Austin, Texas, we began construction, just doing traditional construction means with horizontal directional drilling and aerial construction back in 2014. In early 2015 was when we started developing that business case for micro trenching and presenting it to the city of Austin for their feedback and saying like, hey, what do you guys think of us doing this micro trenching, and what is your feedback? And then in 2016, very early in the year, the first version from Joe's team was released of the micro trenching standard. So with that standard set in hand, we were able to pitch that to the city of Austin to get a trial set up. So in 2016, we were able to do our first trial. It was less than 100 homes that we went out and micro trenched in front of and kind of worked with the city on how that looked and what their thoughts on it were. During that same time, we continued to grow in Austin, getting up to around 3,000 homes over the course of 2016. So really getting that controlled release and getting a bigger sample size of the trial. While that was happening, back at the R&D space in California, multiple methods of micro trenching were taking place. So I'll talk about that in a couple slides as the toolkit approach, but that's an important piece there to remember. So in 2017, we took a big step as a business and moved all of our, moved our primary means of construction over to micro trenching. So as I noted back in 2014, it was drilling and aerial. And then by 2017, we had moved to micro trenching, which was a big step for us. And by the end of 2017, we had constructed more than 500 miles of micro trenching. In late 2017 was when we started working with the city of Austin on their permit requirements for micro trenching. Seeing that micro trenching is such a different application to the roadways than horizontal drilling or aerial work, we wanted to work with them on a better way of permitting this work that was more efficient for them and ourselves. It was in 2018 that the microtrench standards were established with the city of Austin, and we were able to move forward with that, or the permit standards were established with them. And then in late 2018, we continued to iterate on our microtrenching, like I was talking about earlier at the R&D space, where we started working with the city of Austin on, hey, how do we add to this microtrenching toolkit and start and get different backfills for the areas that we're building in. After that, in early 2019, with the more toolkit approach, we approached the city of Austin to do a trial in an abandoned neighborhood. So in the southeast section of Austin was flooded a number of years ago, and they destroyed all the homes, or they removed all the homes. So it's basically a bunch of streets with no houses on it. So we worked with them to do a trial there. Following the success of that trial, we worked with the city of Austin to do a 6,000-foot piece of active right-of-way with the new backfill iterations and trenching methodologies that we had trialed. That was successful, and now we have a continual presence with the city of Austin and are constantly working with them to ensure that the work we're doing in their right of way works for them and is appeasing to all the residents. So moving on to this slide, this kind of goes from early in the micro trenching days to the picture on the right is the trial in that abandoned neighborhood I had talked about. So on the left was that trial where we did roughly 100 homes and then moved into 300 homes. And we ended up building about 100 miles with this methodology here of CLSM sealant. And the feedback from the city was, hey, this is tough to seal on top of because it's so granular, number one. And then number two, it's aesthetically displeasing, or it's kind of ugly to look at in the roadway. So working with Joe's team, we came up with a solution called Gorilla Paint, and we went back and painted all 100 miles of that trenchway to make sure that we were, appeasing the city and making sure that we're helping maintain their roadways and our plan. On the right-hand side here is the trial that we did with the city. So at this location, we actually did 34 different trials. So whether it was offsetting from the curb, what type of backfill, what type of sealant, how wide, how narrow, what type of curb cuts were we doing, what type of backfill in the curb cuts were we using. We showcased all of our different methodologies to the city of Austin so that we could kind of work out what is going to work best for their roadways and what's going to work best for our plant. All right, so the toolkit approach that I've been talking about over the last couple of slides is really showcased here by a few of our engineering drawings. So I pulled 3 drawings here to kind of give an example of 3 different applications. One where we're offset from the curb, we're going 11 inches deep, and we're putting sealant on top of it. Another one where we're going 12 inches deep, we're leaving cable in the bottom, we're T-cutting on the top and backfilling it there. And then the final one that I'm showcasing here is, again, a 12-inch deep cut with that's curb adjacent, where we're backfilling on top of the trench there as well. So as you can see here, we have multiple different options that we've kind of innovated upon, where when we go into a city or we want to start trenching in a street, we have different means and methods that have been proven successfully in order to do that. Because, say San Antonio, for instance, that doesn't have a strong winter, is very different than Kansas City that has a lot of, snow cover and plowing. So we tailor our methodologies to match what works best for the city.
All right. You're welcome.
Okay. All right. Moving on to the next one. Just another slide on the toolkit approach. So you can see here what I was talking about up top with the different trench methodology, but also what we have iterated on in a number of different ways is what type of cabling and what type of conduits go into these trenches. So here you can see 2 different pieces of conduit in the trench, and then just below it is a product that we worked with our partner Duraline on, and they developed for us. So it's a 6 duct bank that fits in a 1.5-inch trench, so you can slide that in and get 6 cables in it. So we have multiple different options that we can mix and match in order to meet the needs of our network. Oh, so excuse me. The backfill here, you can see it coming out of the machine. And the backfill is something we've worked with quite a few different partners on developing, high strength, low strength, what works best in different scenarios, what works best for different road bases and roadways. And then if it's curb adjacent or offset, there's different needs for a backfill as well, which we've spent a lot of time developing over the last few years. And finally, the sealant, whether sealant is needed on a roadway or not. And then again, what type of sealant is needed? What's the roadway? What is going to meet those 20-year requirements of our network and maintain the roadway? So to cover what I just talked about and how this worked its way through the funnel, you can see here, we started off with a brainstorm early on about doing a shallow trenching, hardscape trenching trial, which then led us into the business case of why would we do this, which is because it leads to faster production, which allows us to pass more homes quicker. Following that was our small trial at the R&D facility, and then a trial in Austin, Texas. And then over the years, we've been able to have a controlled release where we're releasing different parts of that toolkit once we found them to be successful. And then that has led into where we're at today of a full release, and we have more than 10 different trenching profiles and standards and bill of materials that work with that so that each city and metro can mix and match to fit their road profiles and their city requirements. So with that, I want to say thank you all for attending. And if there's any questions, feel free to come off of mute, and Joe and I will do our best to answer any questions you have.
I was really curious about maintenance or break fix. If you find a defect in one of the trenches at 11 inches deep, but you got to get human hands in there and you got to get people wrapped around it to maybe fix something in the trench, are you forced to dig out at a diameter that digs out more of the street than anticipated? Can you just dig the street and not the curb, and not, impact the infrastructure of the homeowner's curbside appeal, and you're just approaching it from the street inward? What would you look at in the area of maintenance or break fix?
Joe, you got that one?
Yeah, sure. As we kind of have the toolkit of deployments, we have a toolkit of repairs to these. The Softscape is always our friend in a hardscape repair. The connection between the two, and one thing is with this application, we're doing a lot of surface laterals. So the distance from slack to slack isn't that far. So putting that in the Softscape is often easy. Replacing the actual cable itself between the two slack coils is actually not as challenging as it sounds. But the worst case, if we do have a longer run of this, then there may be opening up a pothole sized hole in the road, kind of an inline splice case to fix it within the road. It's kind of the bottom of our hopeful priority list, but for long runs of this, that may be a solution we use.
Gotcha. So you're able to actually pull back the defective and possibly pull in a new, much easier than trying to find the break and do a repair. Gotcha. Interesting.
Yep. And because, and also depends on kind of what part of the network we're in. A lot of this is utilized in that very last mile, where we do have a lot of slack coils throughout the network. Where this isn't necessarily used, in our longer trunk runs or higher up in the network, where obviously that wouldn't be the case. But where this is deployed in our network, there's obviously a lot of kind of maintenance slack just naturally because there's a lot of service laterals within that last mile.
I have a question. When your maintenance and construction crews hit their stride, what's the productivity look like? So how many feet per hour or drops per day, whatever measure you might think appropriate there? And I'm wondering if you're willing to comment on the cost per mile of this solution.
The production rate can range quite a bit. We've found about a learning curve for a new contractor, even new crew within that contractor. There's probably about a 50,000 foot learning curve where we see them kind of get to a steady state. But that also is dependent on the part of the network, also the market that we're in. As we said, obviously the environment varies drastically across different markets, but that can be anywhere from, on the low end, 1,000 to 1,500 feet a day of pathway footage, kind of independent of how many cables and strands we need in that pathway, up to, we've seen in all great conditions, a mile in a day from an experienced crew that is working in kind of ideal conditions.
Thanks, Joe. Thanks, John. A couple questions here in the chat box. We'll just start with the first one I see. With 60, 100, 120 days of survival test, how do you determine or extrapolate the business case for 20 years?
Yeah, so that was very specific to that one technology that we're running through. Obviously, like on most of our deployments, those are not the checks we're doing. This was, as we've said, that initial gate. So we wanted to make sure we survived that full, I forget what it was, 60, 120, 180, I don't remember. But we wanted to make sure we made through that survival gate, essentially, before we kind of expanded it and continued to put more out there. So these were the fail fast criteria, if you will. In the actual business case for that as a deployment method, I forget what it was, but it was in the 2 to 3 year range that we wanted it to survive. But this was, like we said, that small trial piece where we set up our success criteria before we kind of continue incrementally expanding it to make sure we could get to that full business case. We never made it past, stage 1 on that 60-day. So that's really the idea behind the funnel and the incremental trials we'll do on any kind of physical infrastructure deployment to make sure we've slowly jump each hurdle before we get all the way to that full business case.
Thanks, Joe. Next question here. As microtrenching has existed for many years, why did Google have to repeat this development?
You want that, John?
Yeah, absolutely. So traditionally in telecom, when we had done microtrenching, it had been at the 24 to 36-inch depth where it was used for specific use cases. What we tried to do with microtrenching was shallow that up and use multiple different methods of width, depth, backfill, and try and speed that process up to where we could get to those speeds Joe was talking about with getting close to a mile a day in some instances, which wasn't possible with drilling, and it's rarely possible with aerial. So the idea was that we would do something different than what had been traditionally done in the industry. But by no means were we the first people to put a microtrencher in the ground. We were just trying to do it differently and faster and more efficiently.
Yeah, and I'd add, traditional microtrenching is in our toolkit. Like I've said, a lot of this is closer. This shallow trenching approach may be closer to the last mile. Our F3 splitter boundary kind of area in the network. But traditional microtrenching we may use further up in the network where we want more resiliency. It may be at that deeper depth with some conduit in a lot of parts of our network. So really internally, like we don't even necessarily use the term microtrenching because it's a very broad term. And even when we're engaging with municipalities, it's obviously comes with a lot of thoughts, and people define it very differently. Like John talked through, where we developed kind of a top to bottom toolkit with different depths, different widths, different backfills and sealants, conduit here, no conduit there. It was really developing that full toolkit that we were starting from square one. While microtrenching is not a new concept, it was really defining that 10, 15 different cross sections that kind of fall in that broad microtrenching definition.
That's helpful. Thanks, Joel. Next question here. Does Google have any patents on the technology or parts thereof?
That one, I guess you'll have to send to Google Legal.
Noted. All right. Thank you. Next question here. If you could do the project over again, what would you do differently?
I think that's a tough question, because part of what we were doing is working through that funnel, and where you have parts that are going to fail. I think the thing that we found that was really successful in Austin was when we went out in 2019, when we found that abandoned neighborhood and went out with the city and did 34 different trials with city officials and leadership from the city standing there watching us do it. I think if I could go back again, I would have started with that earlier. It's easy to say that now, but if we could have started that early in the process and avoided some of the back and forth and having to go back and gorilla paint everything because it didn't work, and doing some of those things, if we could have that engagement with everybody all at once, all in the same spot, I think that's something that I would have liked to have done earlier.
Thanks, Sean. Another question here. Sorry, one popped up while I was reading. This one's from Tom, and he says, is growth planned for our triangle? By the triangle, I think he means here locally, RDU, Raleigh, Durham. And is there ROI for adding fiber in Durham?
Unfortunately, neither me or John are part of the triangle team. I know the local team looks at expansion. I know there is some probably already out there, but unfortunately, me and John are not intimately close to the expansion plans in RDU.
Thanks, Joe. And I know that, just for everyone's awareness, Jess George, who is the local contact, had a conflict today. She tried hard to be here, but she couldn't. So we can connect you directly to Jess to help answer some of those questions. Unfortunately, like I said, she wasn't able to join us today. Next question here from Chris. How many development funnels have you gone through now in the history of the effort?
Broadly at Google Fiber, I don't have that many fingers to count up to, but I will say this funnel itself has worked well over the past 2 to 3 years. Things like our shallow trenching approach, things like the fiber tape that we talked through. There's been dozens of things that have made it to various stages through this since we've kind of structured this up. To the kind of the earlier question of what we could have done differently. Prior to that, we didn't really have this really well-structured approach. There was a lot of innovation projects floating around, dozens and dozens that kind of reached various stages of this funnel that we've now created. But back then I couldn't tell you, since we've really put this funnel together, probably a couple dozen. If you consider all of the different shallow trenching approaches as one innovation that's made it through, we probably have a couple dozen different ideas that made it to a business case or made it to our small R&D facility trials here in California. But if you actually go back to the recording and you see that slide, I kind of gave an idea of percentages of ideas or R&D projects that make it through that funnel, and you really see a big drop off as you kind of if 100% of the ideas we have make it to the brainstorming, we eliminate a lot of them when we try and put them on paper and say, does this make business sense? Nearly half of them don't. By the time we put them into a small trial and put something in the ground, more than half of the remaining will fall off. By the time you get to something that is useful, it is 1%'s a guess, but it's a very small amount of the things that have started through this funnel at some point.
Thanks, Joe. Next question. Can you describe how laterals to a house are taken off the main trench?
Yeah, absolutely. So typically a lateral to a house will be one of two ways, depending on what the curb situation is. We'll either drill a pothole right next to our micro trench and then drill or use some sort of pressure vac to get underneath the curb and pull we'll pull the cable to that point, break it out of the conduit, go into the yard, leave a coil, or into the lateral, leave a coil, and then come back out and go back into the conduit and continue down. The other approach is to do what we call a curb cut. So it's just a 90-degree lateral cut. And the fiber that we're using for our F3, F4 routes that are going into the houses are bend insensitive enough where they can make that 90-degree, go into the house or go into the lateral, leave a coil, and then come back out and continue on.
Thanks, Sean. This question here, since micro trenching is smaller than the normal trenching, do you also reduce the sizes of equipment? In other words, do you have any R&D funnels for equipment selection for micro trenching?
Yeah, so we've actually gone through a few iterations on the equipment side as well. If you have seen our crews out there, they're traditionally using the readily available equipment, ditch witches, tractors, the MT12s or 16s. But actually we have gone through processes trying to validate smaller footprint equipment or develop custom equipment. But that actually often falls into the bucket I talked about a little bit on the step 2 here, where us developing equipment doesn't really make sense for our business, but it is something we will engage our partners on, where we have a deployment method. We know this tweak to a piece of equipment may be beneficial to our new deployments, and we'll kick that off to one of the equipment partners we work with. It's often equipment modifications are often something that doesn't make it far in our pipeline because it's not the business we're in.
Thanks, Joe. Those are all the questions I'm seeing. I'll leave it open for another minute or two. If you do have any questions and want to unmute yourself, please do, or you can use the chat box. But we appreciate you, Joe and John, for being with us today. Very informative and very helpful. Really interesting stuff.
Thank you for having us.
Absolutely. Joe, John, what's the best way for these individuals to connect with you if they do think of any other questions? LinkedIn?
Yeah, LinkedIn would be great. My email is jhogie@google.com. Joe, I don't remember what yours is.
Mine is literally just my name at google.com. JOEKUNZ.
Awesome. Thanks, y'all. Well, I don't see any more questions. So we'll end a little bit early, but we appreciate you being here again. And thanks to all of our audience for being with us today. Everyone take care. Thanks, y'all. Bye.